Question 12. A ball is dropped from top of a building at the same time, and at the same time an identical ball B is thrown vertically upwards from the ground. When the balls collide, the speed of A is twice that of B. At what fraction of height of the building did the collision occur? The collision occur. Okay, he's asking what fraction of height. Fine, let's represent what is given in the question. This is your building and you have dropped a ball from here, and at the same time you have threw vertically another ball vertically upwards at the same time, by the way, and maybe in here there is a collision. So when these these two events started at the same time, and you close your eyes, the balls have started, and you close your eyes, the balls have collided. That means both of these have equal intervals of time. Okay, they both took same time exactly to reach the point where they have collided. So in a freely falling body, you have a luxury to have u equals to 0. Why I call it luxury? So because s equals to ut plus half at square becomes s equals to just half at square. Okay, and by the way, he also had given another information. If this is a and this is b, given also given in the question, the velocity, if the velocity of b at this point is v, he is telling velocity at this point of a is equals to 2b. Fine. So he's asking the fraction of height. Fraction of height. Maybe h dash. Maybe he is intending to ask h dash by h. So how do I approach problem? I have u here, maybe I have v, because t is common maybe, and he's talking about the heights and all. So let me take this as s. Fine. In here, in this interval, I have final velocity, I have time t, I have acceleration, and I want s, something like that. So because he's asking fraction of height, right? So that is why I went with this thing. So what is the equation? S equals to, with final velocity it's vt minus half a t square. So then you take a sign convention, whatever direction you want you can take. Maybe because in here all the parameters are in the upward direction, most of them. So I will take my upward direction as positive. So s means h dash equals to vt. Vt is directly v t minus half, a is minus g because g is in the downward direction, minus g t square. So h dash equals to vt plus half g t square. H dash equals to vt plus half gt square. This is one thing I got. So how do I find v relationship between v and t? Maybe I will make use of this interval. So v, you want relation between t, u is anyways 0. Let me use a because it's a known quantity. So final velocity v equals to u plus at. This is my go-to formula. So final velocity 2v equals to g into t, same, because time is same. So v you get gt by 2, implies v equals to gt by 2. So h dash equals to v is, because gt by 2, this is gt square by 2 plus gt square by 2. So you get h dash equals to gt square. So how do we get h? For that interval, for this particular interval, h is, the total distance, displacement traveled by a. So I want s, okay, I know a, so u is 0, okay, because I think, because it didn't complete the entire motion, maybe I will not complete, I will not take this entire motion. So the total height can be obtained by, summing this side plus this side. So in here, in 1, I want height, okay, I know time, I know u, and I know a. So I will go for s equals to ut plus half a t square. So my s is maybe that h dash, maybe h2 equals to u t is 0 plus half a is g t square. So h2 you got half gt square. The total height h equals to h dash or h1 plus h2. So you get 3 by 2 gt square. So if in the question he meant to ask h dash by h, so you get h dash is gt square by h is 3 by 2 gt square. So you get 2 by 3. So the answer is 2 by 3. Thank you.